All right, we are moving on in chapter 3. Today we're going to do section 3 in chapter 3. And we're going to be looking primarily at doing 5-number summaries, box plots, or maybe you remembered from your junior high school days where it was called box and whisker graphs. So we're going to be doing a lot of different things today. But I thought to really set it up properly, we should talk a little bit about what we did in the last section, the last couple of sections, because there was some confusion with some of this. For instance, who would have the most money at age 65? You can see Tom at age 20 is putting $5,000 in a year for 20 years. $5,000 a year for 20 years is $100,000. Sarah, age 20, is putting $10,000 in a year for 10 years. $100,000. They're both putting $100,000 in. Who would have the most money at age 65? Because both of them are starting early. The money's going to sit there in compound interest over the years. Who's going to have the most money, or would they have equal amounts? They put in equal amounts, but it's no contest. Okay? If you compare these two, Sarah is putting more money in earlier. In the first 10 years, she's done after the first 10 years. That money is going to sit there and grow and grow and grow. No contest. She wins. All right, let's talk about, we were doing bell-shaped curves with standard deviation. Shy Sam does not like to date girls that are smarter than what he is. So what we want to do here is we have a bell-shaped curve, okay? Sam's IQ is 85, mean IQ is 100, so down here is 85, okay? Everybody see that? All right, standard deviation sample, standard deviation is 15, okay? Find the percentage of girls smarter than Shy Sam. So what we are looking for right here is this region. These are all the girls from here over that are going to be smarter than Shy Sam. Now, if you remember the empirical rule, 68.26%, 95.44%, 99.74%. This is 1 standard deviation, 2 standard deviations, 3 standard deviations. That's the percentage of data found within 1 standard deviation on either side, 2 on either side, 3 on either side, okay? All right, so now if we look at this, standard deviation here is 15. That is 1 standard deviation below. So if we would go 1 below and 1 above, 1 below and 1 above, you would know just between these two, there's 68.26% of the data. Okay, so we need to know yet how much more is over there. So if you take 100 minus 68.26, I get 31.74 for this area left over and that area left over. Divide by 2 is 15.87. Now, I don't care how you do this. You can take 15.87, which is that much, and add it to 68.26. And we get 84.13% of the girls, quote, 84.13% of the girls are smarter than Shy Sam, okay? Or the other way you can do it, we know that down here, that whatever was left, it was 15.87. Yeah, 15.87 is down here. You could have subtracted that off of 100% and got the total amount of girls smarter than Shy Sam, okay? Suppose Shy Sam had an IQ of 70. All right, so let's start over. Suppose Shy Sam has an IQ of 70. He's right here. We want to know he would be smarter than what percentage of the girls. So now we're interested in that region down there. So let's start all over again. 70, would you agree that it's 2 standard deviations below? Okay, So if we would go 2 below and 2 above, 2 below is 70, 2 above is 130. Yes? Okay? 2 below and 2 above should contain 95.44% of the data right in here. We want what's down here. So you're going to take 95.44 and subtract it from 100. Get that answer. That gives you the region down here and the region up there. So divide by 2, and I get 2.28% of the data. So Shy Sam, if he has an IQ of 70, he is smarter than 2.28% of the girls. All right? All right. Let's go on. I think I better draw a new picture. Okay, so let's start again. So here we are. 100's in the middle. It says, what percent of the people have an IQ between 85 and 130? Between here's 85 and here, way over here, is 130. Now, this is a little tricky. 85 is 1 standard deviation below. 130 is 2 standard deviations above. Are you with me? Okay, so we want to know what's in between 85 and 130. Okay, now 1 standard deviation below and above. If you went down to 85 and up to 115, you'd have 68.26. So what I'm going to do is take 68.26 and divide it by 2. This region right here would have 34.13 because it's 1 below. This one is 2 standard deviations above. So if you went 2 above and 2 below down to 70 to 130, you'd have 95.44. We only want half of that. So 95.44 divided by 2 is 47.72. Okay? So now all you have to do is add those two together, and you will have the percentage of people that have an IQ between 85 and 130. Okay? Next picture. 2.28% of all people have an IQ lower than what? Okay, so here's 100. 2.28, we know it's 50% up to 100. So 2.28 is going to be way out here. So there's some IQ that this shaded region is 2.28%. Are you with me? So 2.28% of all people have an IQ lower than what? That sounds just like the Shy Sam problem of before. I'm betting it's going to be 70. How can we figure it out? 2.28 down here, there would be the same question mark up here. So take 2.28 times 2, okay? Then subtract that off of 100. You get 95.44%, okay? So we know it's 2 standard deviations below and above. So what does this have to be? Just what I had said earlier, 2 standard deviations below, 2 15s would be 30 below 100 or 70, okay? 49, last one here. 87% of people have an IQ between 100 and what? All right, so let's start over again. Now, this question says we're between 100 and something out here. So we know that this region here is 49.87%. Yes? So what is this over here? Well, that's half. So why don't we double that? So 49.87 times 2 is 99.74. So if you double it, you know you're 3 standard deviations away. 3 standard deviations is 3 times 15 is 45 plus 100. This has got to be 145. Okay? Everybody with me on that? I thought it would be important to talk a little bit about that before we go on, because when we go to box plots, we're kind of leaving standard deviations and the empirical rule behind. Okay, so I just wanted to touch briefly on that. All right, so now, if you recall, one of the first things we did in chapter 3 was we talked about how the mean, the average, is sensitive to extreme values. If you have some data and you have some horribly, horribly big ones, it's going to pull the mean toward the big ones. If you have some data and some extremely, extremely low values, it's going to pull the mean toward that data. So the mean is sensitive to extremes and it's not resistant. Percentiles, what we're going to get into today, uses the median and is therefore much more resistant to extremes. Okay? Remember the whole Warren Buffett thing, if he moves into your town, remember how it shifted the average and so on. The median does not shift like that. Okay, we're going to use quartiles. Now, before I go any further, you probably all took a test when you were back in grade school, high school, junior high, middle school, and you were probably told something like, you placed in the 93rd percentile, all right? Do you understand percentiles? The 93rd percentile means that your score was higher than 93% of the data, okay? That's percentiles. So we're going to start out using quartiles. Quartiles, Q1 will divide the data into the first 25%. Q2 divides it in half. Q3 divides it into 75% of the data. Okay, and so on. And let's check out figure 3.7 on page 116. 3.7 shows you how if you divide your data and you have different kinds of data, what it's going to look like. Way at the top of page 116. Okay, left skewed, right skewed, uniform, bell-shaped. It simply divides the data so that there's 25% of the data in each part, okay? And depending upon the shape, it's going to look different. So let's get started. These are the hours of the amount of TV that people watch per week, okay? Now, to do this, if you're going to do this, you've got to get the data put in order. All right, and this is always a pain in the neck. So what have I got here? I've got from 20, looks like that's, no, 5 is the smallest, okay, and it goes the whole way up to, what, in the 40s? Oh, somebody watches a lot of TV, 66. So it's going to go the whole way from 5 up to 66. So let's see how we can do this here. I'm just going to try to get it all along across the top here and see if I can squeeze it in. So I have 25. I've got 41. I've got 27. I've got 32. 43. 66, way out here. Okay. 35. 31 here. 15, 5, 34, I'm starting to run out of room, 26, okay, 32 again, another 32, 38, 16, 30, yikes, 38 again, 30 again, 20 and 21. Okay, so yeah, I have, how much data do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, darn it. Did I, 1, 2, 3, 66, there it is, 20. Okay. Now, you've got to find the median of the data to find your Q2, which will separate the bottom half of the data from the top half. Okay, so there's 20 items of data. I'm going to count up 10. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm after 30. Okay, there's the dividing line. If I come down 10, 3, 4, 5, 6, 7, 8, 9, 10. I'm in between 30 and 31. Are you with me? So Q2 is 30.5. Okay? Now, was the 30.5 a data item? No, it wasn't. We had 30 and we had 31. 30.5 is not data. So when you go to do Q1, you've got to take these 10 items up to and including this 30 and count up 5 and down 5. Okay, you do not count the 30.5. So I'm going to come up 5. 5, I'm at 21. Come down 5, 1, 2, 3, 4, 5. I'm in between 21 and 25, and is that not 23? So Q1 is 23. Same thing happens on this side. I have 10 items of data. Okay, so I'm going to go up 5. 1, 2, 3, 4, 5, and come down 5. 1, 2, 3, 4, 5. I'm in between 35 and 38. So Q3, in between 35 and 38, should be 36.5. Okay? So there is my Q1, Q2, and Q3. Interpret using percentages. 25% of the data is in the lower quartile. 25% of the data is in between these two. 25% of the data is in between these two. And 25% of the data is from 36.5 and up. Okay? What if I remove the 66? Okay? I'm going to remove the 66. And I'm going to redo it. Okay, so let's talk about it. Without the 36, without the 66, there are now 19 items of data, not 20. 19. So I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to come down 9 without counting the 66. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm in between this 30 and this 30. Q2 would be 30 in between those two 30s, okay? Whoa, let me count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then come down 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, I forgot the 31 there. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm in between this 30 and this 31, which is that 30 right there. Okay? That 30 right there. Is it an item of data? Yes, it is. Okay? So now you have 10 items of data in the bottom half, counting that 30. And you have 10 items of data in the upper half, counting that 30. Okay, so when you go to do Q1 without the 66, you must include that 30 in the bottom half. When you go to do Q3, you must include this 30 in the upper half. Yeah? All right, so if there's 10 here, we go 5. 1, 2, 3, 4, 5, and count down 5. 1, 2, 3, 4, 5. I'm in between 21 and 25, which is what we were before, which is 23. Okay? Now I go from here, include this 30, go up 5, 1, 2, 3, 4, 5, and come down 5, 1, 2, 3, 4, 5. I'm in between 34 and 35, and I'm going to have to double check that. Something just doesn't seem right. Yeah, I'm right. I don't know why I was second guessing myself. All right, so let's finish this. Here's the 30 right here, okay, which is an item of data. So you include it with these 9. So that makes a total of 10. And I go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. I'm in between 34 and 35. So Q3 is 34.5. Okay? Now, if you look at this, by throwing out the 66. Look at this. Hardly any change at all. Hardly any change at all, right? The 66 would have really affected the mean. When you throw out the 66, the mean would have dropped significantly. But because we're doing medians, it does not drop, okay? All right, so we've got everything, we're down to the interquartile range. Okay, so let's get rid of this and go back to where we were, back including the 66. The interquartile range, the IQR is Q3 minus Q1. So that's really easy. 36.5 minus 23. The IQR is 13.5. Yes? Okay. Now, use 50%. Okay. Between Q1 and Q3, there's 50% of the data is between Q1 and Q3. And it's spread out over 13.5. All right. How about the 5-number summary now? Your minimum value is 5. Q1 is 23. 30.5 is Q2. 36.5 is Q3. And the biggest one is 66. There's your 5-number summary. Okay. A spread per quartile. We have a spread of 18 in the first quartile. I'm just subtracting. A spread here of 7.5, a spread here of 6, a spread here of 29.5, I think. My brain is working, okay? So you can see which quartile has the most spread. I think it was this last one because the 66 really spreads it out. All right? Now, we want to talk about this 66 and possibly the 5. They're way at the ends. Is it possible that they're an outlier that really doesn't have anything to do with the rest of the data? We need to talk about that. All right, so we're going to find the lower and the upper limits to see if they really are. To find a lower limit, you take Q1 minus 1.5 times the IQR. So I'm going to take Q1, which is 23, minus 1.5 times 13.5, and I get 2.75. So the lower limit is 2.75. The upper limit would be 36.5 Q3, so 36.5 plus 1.5 times 13.5. Okay, that gives me 56.75. All right, those are the limits of where the data should be. Okay, is all the data confined within those two limits? Well, we're okay with the 5. It's in there. But look at the 66. All right, it is not contained within those two limits. So we must establish that this one right here is a potential outlier. Okay, and we're going to illustrate that when we draw it on our box and whisker graph. Okay, adjacent values are the extreme data that are within the limits. So my adjacent value here is the 5, which is still acceptable. The adjacent value here is the 43. That's as high as the data should go. The 66 is no good. No outliers implies that the adjacent values are the min and max, like the 5 was okay, but the 66 is not. Oh, what is this? Outlier. If you have a point that doesn't seem to fit the rest of the data, that point is crying, your theory is wrong, your theory is wrong. Well, that must be an outlier, and we're going to erase it. We're going to get rid of that. Love the statistical cartoons. All right, so let's draw a box plot for this data, okay? We have found the quartiles, we found the IQR, we found potential outliers, adjacent values. Draw an x-axis. So we draw an x-axis, okay? We need to go from 5 to 66. So I think what I'm going to do is 10, 20, 30, 40, 50, and 60. Here's 5, 15, 25, 35, 45, 55, and 65. All right, lowest value is 5. Put a dot. 23 is next. Put a line at 23. 30.5 is next. 30.5 is right about there. 36.5 would be right about there. And then 66. 66 was an outlier. You put an asterisk, okay? And you put the adjacent value, the highest data value permissible, 43, we put a dot. Okay? Now we draw it. Line connecting, and make a box. Okay? It's called a box and whisker graph. All right? The only difference is because that was deemed to be an outlier, we put an asterisk there and we stopped it at 43. Okay? Your 5-number summary is not affected by that 66 being an outlier. It is still there, 66. Are you with me? Okay? But just make sure your x-axis is uniform, 10, 20, 30, nice spacing. All right? Okay. We can talk about spread now. Before we leave this picture, look at the way this is drawn. The tiniest amount of spread is in Q3. If you look at Q3, it goes from 30.5 to 36.5, a distance of only 6. So there's not that much spread, okay? But the picture really shows that well. If you look at table 3.13 and figure 310 on page 122, jump over to page 122. And on 122, we have at the top of the page, we have runners and just regular, normal, everyday folks. And we're looking at skin fold thicknesses. Skin fold thicknesses. Or as my wife would say, I'm a skinny thing, and I don't have much when it comes to skin fold. Might have something to do with that fact that I'm also a runner. Look at the 2 box plots on page 122. The runner is the little group up in the upper left-hand corner, and the normal folks is the other one. Look at the spread. You've got people way spread over all the range of thicknesses, and like 90% of all the thicknesses are bigger than the runners, okay? And the runners are grouped very tightly down between like 5 and 10, all right? Very, very, very well illustrated what's going on here. Okay, I'm going to get rid of this one totally. So let's get rid of this. And the offensive 66. All right, now we want to do quartiles, 5-number summary, identify outliers, limits, construct box plot for this data right here. How many items of data? 1, 12 items of data. Okay, so here we go. We're going from a low of, well, we're going from the lower 300s to the middle 400s. Okay, so let's see if we can get that in here. So we have 352. I've got 374. I've got 400. I've got 426. I've got 396, which would be right in here. I've got 427. Okay, 445. Way over there. 434 is here. 400 again. Another 400. 354. 374 again. And 349. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Okay, got them all. All right, let's go through the whole thing. There's 12 items of data. We want to first get the middle, the median. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm dead in the middle of 396 and 400. Okay, is that not 398? So Q2 is 398. Okay. Now, was the 398 a data value? No, it wasn't. So you don't include it when you're doing the Q1. There are now only 6 items of data. You don't count this one and say that's the 7th item because it's not data. All right, so we're going to come up 3 and we're going to come down 3. I'm between 354 and 374, which should be 364, Q1. Does this one count in this group? No, 398 is not a data item, so I just deal with those 6. I come up 3, I come down 3, I'm at 426.5 for Q3. Okay, let's get the, we got the quartiles. The IQR is Q3 minus Q1. So I have 426.5 minus 364 is 62.5. The IQR is 62.5. Okay, 5-number summary, lowest value, 349. Q1, 364. Q2, 398. Q3, 426.5. And the highest value, 445. There's your 5-number summary. Okay, let's check for outliers. All right, so for outliers, we want to take Q1, 364, and subtract 1.5 times 62.5. Yeah? And I get 270.25. The lower limit is 270.25. What about the upper limit? I would want to take Q3, 426.5, plus 1.5 times the 62.5. I get 520.25. Does the data fit between those bounds? Easily. So there are no outliers. Okay? Let's do a box plot. Box plot. We need to go from the middle 340s to the middle 440s. So how about we do 350, 360, 370, 380, 390, 400, 410. Should have made it a little longer. 420, 430, 440. Okay? And now, 5s halfway in between are your 5s. Okay? Nice uniform graph. All right, here we go. 349, just barely below 350. 364 is a line. 398 is a line. 426.5 is a line. And 445 over here is a dot. The box is in there like this, and the whiskers come down like this. Okay? It is a fairly symmetrical box. I mean, the spread in the middle is huge. All right, but you can almost see it would be like a bell curve almost here. Not quite as much spread here or there. Okay? Pretty interesting. Pretty interesting stuff. Okay, you're going to be doing a lot of practice on that. Notice I changed the directions a little bit on 3.132. So be on the alert for that change in directions.